Okay, so question 9 quickly says this is electrodynamics. The simplified sketch below shows or represents the structure of the motor on the cordless what. This is the motor, right? So can you see the current moves and this is negative, this is positive. Remember, it moves from negative to positive. Okay, even if they do not show you this, you need to know that it moves from negative to positive, so it's gonna move in that direction like that. Okay, sharp. Name name the electrical component in the above motor that ensure that the coil rotates in one direction. So this is the work for the split ring. Again, the split ring commutator here. Okay, the split ring basically. The split ring is the one that makes the thing to be to do what to ensure that the coil rotates in one direction. Okay, remember this is a DC. Why? Because it is split like this. So I can say this is DC. Split rings. Okay. Identify the polarity of magnet A and B if the current flows in the coil as indicated in the above sketch. Okay. So we need to know which one is north, which one is south. Now, if the current is moving towards me, so I need to, when I use, remember, this is motor. So for motor, we are saying, remember, we say, God rules my life. Motor left hand rule. So I'm going to use my left hand rule and say the current, which is the third one. I'm not sure. Let me do this. The current, which is the third finger, the off should point towards you because it is okay, like it is moving like that towards you. Okay, so the third finger should point towards you, the middle finger should point towards you, and then this one. Let's see, this one, it's gonna rotate. Let's focus on this side. Okay, we are told that, can you see? We are told that this side is gonna move downwards. So if this side is gonna move downwards, can you see? We are told that it's gonna move downwards. This side is gonna move down. So it means your thumb should move downwards. Your thumb should move downwards. Try to twist your hands such that your thumb moves downwards, and then the middle finger points you. If I get that, I get that the electric field moves from B to A. Try to do that as neatly as possible. I repeat, the middle finger should point at you, and then your thumb should point down. But can you see when you twist it like this, your middle finger will move away. Just make sure you rotate your hand such that it moves towards you, and then you'll see that your second finger next to the thumb and next to the middle finger is pointing towards there. For me, it is left. So from B to A. So it means this is north, this is south. Okay. Yes. So if it rotates anti-clockwise, this is clockwise, this is anti-clockwise, like that. So yes, B is north, this is south. Cool. 9.2, define RMS current. You should know this off by heart. You'll know this off by heart. Okay. So this is how we define the RMS current. The RMS current is the alternating current that dissipates or produces the same amount of energy as equivalence DC direct current. If you explain RMS voltage, you'll get 0. Calculate RMS current that the drill draws when operating. Okay, I think I did not read the English here. So they say the maximum current output of another drill operating on an alternating current, it is this one. Okay, so we have I max is equal to 10.6 amps. The graph of the potential energy, potential output, it is shown like that. So here it is. So they want us to calculate the current RMS current. So remember RMS, you have your maximum. Okay? You just need to divide by that by square root of 2. And then it's going to be I max, it is 10.6 divided by square root of 2. Then it will be just easy calculations. And it's going to be 7.495, which is 7.5 amps. If my calculations are to be correct. Okay. And then hence calculate the average power. Okay. The average power, remember PA is going to be, what am I given? What am I given? No resistor. So I can say PA, it is V RMS multiplied by I RMS, or PA, it is equal to V max multiplied by I max. Whatever that you use, they should match. Okay, since when we do not have I VRMS, we use Vmax. Vmax here is 300. Okay, 300. Imax, it is 10.6. Sorry, if I'm not mistaken, it's supposed to be like that. And then we get something like 300 multiplied by 10.6, 3180. 10.6, 3180. This is power watt. Okay. Okay. And then, is this the final answer? No. Why? Because this is just T max. Okay. But we just calculated here it is P max. And then, so for me to get P average, I need to say it is this amount divided that by 2, which is now 1590 watts. But when I just want to go to P average, I can use VRMS. VRMS, I know it is the same as P max divided by square root of 2 multiplied by IRMS. So V max, it is 300 divided by square root of 2. And then my current, it is 7.5 here, right? 7.5. And then let's see if the power is the same as the average that I calculated there was. Gonna be 300 multiplied by 7.5 divided by root 2. Well, I get 1590 point, actually 1591 watts. So it is more or less the same. So is the power generated by the drill TO at T1 maximum or minimum at T1? At T1, power generated at T1, we see it is the maximum. Okay, if it was going to be minimum, if it was here. So this is just easy maximum. Okay. Provide 2 reasons why alternating current is preferred over this one. There are good reasons because AC can be transported over a long distance, okay, and it can be stepped up or down, okay. So yeah, and there is a low current due to its high velocity. So we can say it can be transported over a long distance as it can be transformed, okay, stepped down or up to minimize power loss. And it is easier to generate AC current. And then higher voltage means lower current. And then now it means our power off will not be that much and it won't be dangerous. It will be easier for us to control. Okay, so yes. And then let's go on to the last question. Last question.